Good morning, first years. I'm going to go through the Google Forms first year coordinate geometry test that I gave you last Thursday. So hopefully you can see this okay. I'm doing it through screen sharing and we'll see how we get on with this. So to begin with, you had the front page where you could attach your rough work. Some of you were able to do that through the form. Others needed to email it to me afterwards separately, and that's fine. So you type in your name here. And then on to the first question. So for question 1, you were asked which axis do each of the following points lie on, and whether it was the x-axis or the y-axis. Now the x-axis, all along the x-axis, we have different values for the first coordinate, 1, 2, 3, 4, 5, etc. And y will be 0 because you don't go up or down at all. So anytime the y value is 0, the point lies on the x-axis. So for part 1 and part 2, both of these points lay on the x-axis. For part 3 and part 4, the x value is 0. So they're not going left or right at all, only up and down, and those points lie on the y-axis. So for part 3, it's the y-axis, and for part 4, it's the y-axis as well. And then part 5, 0, 0, the origin. It's on both. It's on both the x-axis and the y-axis. It's where they cross over. So that was question 1. Question 2, which point is displayed here? So I was checking, did you understand when we're naming points that we use the x value first? So the x value is -5, followed by the y value. You go over to -5 and up to +2. So it's the point -5, 2. In question 3, I had asked you to draw a coordinate plane going from -5 to 5 in all directions and then to plot the following points. So I'm going to do this on the board behind us, excuse me. And hopefully you can see this okay. I won't be using a grid. See how much space you can see there? Okay. So we're doing a coordinate plane between -5 and 5 in all directions, and I wanted to see your x and y axes labeled like this. You can see that okay? And we go 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5. And of course, yours will be on a grid, so each of these will be right on the intersection of boxes. And it's just like 2 crossing over number lines, 4, 5. So you'll have a grid as well, but hopefully you can see that okay. And then I wanted you to plot several points. The first point was the point A, which was -2, 2. So x value first, -2, and then up to 2. So A was the point -2, 2. And I wanted to see it. You don't have to put in dotted lines or anything like that. I'm just trying to make it clear for you. And there's a bit of a shine on the board, so let me just bring this closer. So A looked like that. And the next point, excuse me, was the point B, 0, 5. So I don't go left or right, but I do go up to 5. That was the point B. Right beside it. B was the point 0, 5. And then we had the point C, which was 1, 4. So over to 1, up to 4. There's the point C, 1, 4. Over to 1 and up to 4. The order is important, so that's what I'm looking for here. And finally, D, -3, 0. So you go over to -3 and you don't go up or down. So that's the point D, which is -3, 0. So all of the points were actually up here, but I wanted you to draw this part as well in case you were getting them backwards, that I'd be able to see what types of mistakes you're making if you are making mistakes in plotting points. Now, question 4. We're asked to write down the coordinates of these places on the given map And you just have to type them in here. So A was Smuggler's Creek, and hopefully you can see here, Smuggler's Creek is over at 8 and up to 2. So Smuggler's Creek was at 8,2. B, the lighthouse. So the lighthouse is over to 7 and up to 5. So the lighthouse is coordinates are 7, 5. And C, Sandy Cove. So Sandy Cove over to 4 and up to 4. So Sandy Cove's coordinates are 4, 4. Next, in question 5, we were asked to write down the names of the places on the map with these coordinates. So the coordinates 1, 5. 1, 5 is the caves. Next, 6, 3. Over to 6, up to 3. 6, 3 is the pool. Part C, 3, 0. Over to 3 and don't go up or down. And we're at the pier. Part D, 2, 2. Over to 2, up to 2. And you get to the evergreen tree. Okay, so I wanted you to be able to plot points, write down the points of where something is, and name things when you're given the points as well. Now, question 6. When finding the shape of an image under axial symmetry, so you're reflected in a line, the image will be reflected, okay? A mirror image, but it's not turned upside down. When finding the image of a shape under central symmetry, the image will be turned upside down and reflected. Okay, that's when it goes through a point and it gets turned upside down and reflected. So it's both inverted and reflected. And when finding the image of a shape under a translation is when we just move the shape, the image will be exactly the same as what we started with. So it won't be inverted, it won't be reflected, it will be neither. The next question was about axes of symmetry. How many axes of symmetry does a rectangle have? It has 4. I wasn't asking you to draw them, but if you did that as part of your rough work, you know, if you got this question wrong, but I could see some work towards axes of symmetry on your rough work, that would give you partial credit for this question. How many axes of symmetry does this shape have? And our equilateral triangle has an axis of symmetry through each of the vertices. So it has 3 axes of symmetry. And this one here, now a square has 6 axes of symmetry, but this is not a square because of this semicircle that's in the middle of it. It only has 1 axis of symmetry. Okay, if I try to draw a line through any of the other potential axes of symmetry, it's not an exact reflection. Right, question 12 then. Write the answers to A, B, and C in the space provided. Which of the transformations will map K to L? So here's my object K, and to go to L, it's exactly the same shape, it's just moved. So for part A, K to L will be a translation. Part B, L to M. So L to M is a reflection. It's not turned upside down and reflected. It's just a reflection in, actually probably in the line just over here. So if I fold it along, if you fold it along the line -1, if you fold it along this line, you'd find that you get an axial symmetry. So to map L to M, we have B, a reflection in a line. And the particular line, which I wouldn't expect you to identify, would be the line y equals -1. That's a bit more advanced. And part C, mapping L to N, okay? So we can see that it's reflected and inverted. It's turned upside down and it's back to front. So this was a central symmetry. Okay, so the three different options there. And that was all of the questions. So hopefully everybody was able to write down something for every question. I will get your results to you as soon as possible. But for today, all I want you to do is to go through the corrections there and let me know if there is a solution that you don't understand or that you have a question on. Okay, thank you all very much. I'm going to stop screen sharing and we will stop this.